Guys, welcome to my YouTube channel. In this lesson, we are going to learn about a C++ program that is a voltage level classifier. As you can see from here, voltage level classifier, what it means is that this program is a voltage level classifier that will classify your input voltage. So if your input voltage is less than 50, it will be classified as low voltage. But if it is more than 50 but less than 240, then it will be classified as a normal voltage. And if your input voltage is greater than 240, but less than 450, then it will be classified as high voltage. Else, then it's classified as a dangerous voltage. So let us go through and look the program and understand each line of code of the program. Okay, so first I'll begin with the first line, where is the hash include IO stream. Now, to type C++ program, it is very important to always type this first line code, because it is this line code that help us to make use of the input and output functions. So the count here is the output function, whereas the CIN, which I call it sin, is the input function. So without the hash include IOS string, we can't use the count in the scene. Yeah, so I'll talk about what they are used for as we continue diving in. Okay, they're using namespace std. We write it so that when you are using the output in the input function, we don't need to type std, then is to for both the count and the scene. We don't need to type this one because we're using namespace std, because without typing this in, just typing this in, we can waste more time if you have to type so many count and scene functions. Okay, so let's move to the next code line. But before I explain about the fourth code line, let me explain about what these lines are. You see, these lines that are colored light blue, it tells you that they are comments. How do I know that these lines are comments? It's because of the double forward slash. So if I clean the forward slash, you see it will appear as black. So the forward slash will let your statement be a comment. So comments are needed to explain your code. And if you run your program, your comments will not be run. Nothing will happen to the comment even if you run it, if you run your program. Okay, so let's move on. So now let's move to the next line, which is line 4, the int main function. It is where every C++ programmer types their code. So you type your code in the int main function. So you type it from the open curly brackets. Mostly we type it under the int main function. So this is where we type all our code, in the int main function. So we get to the end here. Okay, so like I said, the int main function is where you type your code. So you know this one is already a comment, as I have explained previously. Now here, from the comment, it says declare a variable to store the voltage reading. The comment is trying to explain this code line. So what it means is that if I type float voltage, I am declaring a variable. It's like I'm creating a variable, and the float there is there to make the variable store decimal. So we can have decimals like 12.5, 15.2, or 20, or 30. Even integers are decimals. Then let's move to the next line with the output and input function. So here count, then you can see two less than symbols. So the two less than symbols is there to help the count function to display the statement on the screen. So if you run your program and because you've used the count with the two less than symbol, this will be displayed on the statement. This will be displayed on the screen, sorry. So we use the count function to display statements or any form of symbols on the screen. And remember, for strings, they must always be in in code, we use quotation for strings. And I forgot to explain that every code line must end starting from the using namespace. Every statement on the code line, well, not all statements on the code line. Like if you are creating a variable, you must terminate it. If you are using the count and the scene statements, you must terminate them. So this is what we use to terminate it. Because if you don't terminate them, meaning if you don't indicate, if you don't end it with a semicolon, your computer will not run. So you must end it with a semicolon. Okay. Now the CIN, which stand for character input, is there to allow user to input their values. So when a user input the value, the CIN will receive the value. And you see, instead of using less than, I use greater than to let you know that the scene is going to receive the input. And because I bring the variable voltage, the scene will transfer the input from the user to the voltage. Okay, so let's continue. And from here, beginning with if, this tells you that this is an if else statement, which is very important for our program. So our if else statement ends at else. But as you can see, it is not just an if else statement, it's an if else if statement, because this block of code is using else if statement. So we call it an if else if statement because of the use of else if to finally the else statement. Okay, so when you are writing your if else if statement, here you will bring brackets to state your condition before the program can execute its function. So the condition that you stated here is voltage less than 0. What it means is that if the value of the input for voltage is less than 0, then the computer should what? Print invalid voltage reading. So the count is used to print, so it should print invalid voltage reading. So if a user inputs value which will be stored in the voltage using the CIN, so to transfer the input to the voltage. So if the value is less than 0, then the computer should print this statement. But if it is not, then the computer will try and run the next else if statement. So it means if this condition is not met, the computer should try and check the next condition, which is the else if statement. So if it is less than or equal to 50 but greater than 0, then the computer should print what? Low voltage. Should print low voltage, then with what? A bracket there. Okay, but before I explain this one, let me explain the end L. The end L means after the computer prints this statement, the computer should move to the next line of the screen. So when the computer moves to the next line of the screen, then it means that on the next line of the screen, if the computer wants to print something, it will print on the next line of the screen. Okay. And remember, you must always end it with what? A semicolon to terminate the line, to end the line. So if this condition is not met, we use the else if statement. So if this condition is met, then it will print. But if it is not, then we move to the next condition using the else if statement. If it is not met, we move to the next condition using the else if statement. So the computer will run the program when a condition is met. So the else means that is the final condition if all the conditions are not met. So the else means then print this one if all the conditions are not met. So you will use the else to end so that the computer can print dangerous voltage if all the conditions are not met. Yeah, but let me explain one more thing else. You see, in the count we write low voltage here, which is between the quotation mark. Then later we bring less than. What it means is that The computer, yes, the less than is telling the computer that it should print low voltage. Then we brought another less than. It means that the computer should print what is here next. So here we indicate a variable called voltage. And you know the voltage, it stores the input from the user. So the computer should print. When you bring the less than, it means the computer should print the value of the voltage. Then the computer should later print what? This statement. Then the less than means the computer should move to the next line, where is the end L. So the same applies to here and here. Okay, so that is it. So the else means if all the conditions are not met, then print this one. Okay, so let us run the code and see what will happen. So you run it from here. So you send the cursor to this side, then you tap it so it will run. So remember, if the voltage is less than 0, negative 12, so that is my condition that I've given. So my input is less than 0, which is a condition. So if this condition, which is the first condition, if it occurs, then the computer should print the result for the first condition. So you see invalid voltage reading. So that is what so it has printed the invalid voltage here, which you can see it on the screen, because the condition, if it's less than 0. Now if it is less than 50 but greater than 0, then you should print what? Low voltage. So let's run it again. See, so I'm running it again. So if it is less than 50, so let's type 45. It's a voltage 45, but here they say low voltage because the condition says if it is less than what? 50. Okay, so let's run it again. If it is less than 240, then it will print normal voltage. So less than 240, so let's use 235. So normal voltage. Even if you type 240, it will still print normal voltage because the condition says if it is less than or equal to 50. Okay, less than or equal to 240, sorry. Okay, so let's try and obey the fourth condition. If it is less than or equal to 450, so let's run it again. If it's less than or equal to 450, so let's type 450 and see what will happen. High voltage. Sorry. Okay, so what if none of the conditions are met? That is for the else. If none of the conditions are met, what would it print? So that means if I could type a value greater than 450, you see, it doesn't obey all the 4 previous conditions. And it seems there's a problem, so let me run it again. So if it's greater than 450, so let me type 500. Dangerous voltage. So you see all the 4 conditions, if they are not met, then you should obey the 5th condition. So yes, our program is classifying our inputs. It classifies the first one as low voltage, normal voltage, high voltage, and dangerous voltage. So yes, our program is working correctly. Therefore, we've created a program that acts like a voltage level classifier. Thank you for watching the video, and I hope you understood the video.